Overheating or something. All right. Sorry for the disruption. All right. So before the connection got disconnected, we were talking about the JSON file format. All right. So let's just go briefly over and also save the notes in case of similar disaster. Okay. What is that? Today's date is 10 October. All right. All right. So is everyone with me? Are you able to hear me clearly? Ishwar, are you able to hear me clearly? All right. All right. So before this connection got broken, we were talking about JSON format. All right. JSON format looks like this following. So in very simple words, JSON format is made up of objects, and an object is represented like a curly brackets. Okay. So this is the name and this is the value. Okay. So now the value could be further another object. Value could be another object. Say, for example, value could be or let me try to represent a car. Say, let's say we are representing a car and we are saying model is some Hyundai or say Honda and something, and under that we have got say parts. Okay, parts could be an array. All right. So again inside an array it could be an object or it could be further an array. So this is how you represent a complex object in JSON. All right. Using curly brackets we represent a complex object, and each complex object is have uh, name and value. All right. And the value could be an array. So essentially there are three kinds of data types in JSON. Okay. One is called object, okay, represented by curly brackets. Number two is array, represented by this, okay. And number three is the actual values, such as this is a string, or such as some number like 10, or a decimal number like this. Okay, so using these constructs you can create anything you want. All right, let's say you want to create a customer object. So you could say there is a name of the customer. Okay, some name of the customer, it has got an ID, some ID. You can put, these are arbitrary, you can put anything you want. Okay, orders placed could be orders placed, these are all in double quotes. Okay, orders placed could be in the format of an array, and here inside an array there could be further objects or value or anything else, or it could be an string. Okay, order. Okay, so it could have some order ID equals to 10 and so on. So this is how a JSON is represented. In case of XML, the way we represent data is we could say customer, and under that we could have something like that, and we would be having say further maybe here an ID equals to 111, and then we would have further orders placed, another orders, okay, something like this, and under this there will be order, and it's order underscore ID equals to 10. So I'm trying to represent the same thing in XML what I've just done. Okay, then there could be another one where we have something else and so on. Okay, so now is it clear what does JSON look like? Yes, it can be anything. Jitender? So Jitender's point is, so it can be more object, yes, like car, bus, etc. It could be anything. All right. Now his question is, then it's not a text file. Okay. So I would say it's basically a text file. If you look at XML, XML is also saved like a text file. You can open an XML in any plain text editor and edit things. It's not that complex to edit. All right. Similarly, JSON can be edited. It's not binary file, so we can edit it at any point of time. I'll show you. So let's say take, do we have stocks.json here? No, we don't have. All right. Now going back to what is it? We were dealing with this one. Oh, I need to reconnect everything. All right, SSH. And JSON is quite a popular format, even in the web programming. The browsers communicate using JSON format mostly. If you look at the network traffic in your Chrome, you will see a lot of JSON traffic going on. Because JSON is quite lean, as you can see here. If you try to represent the same thing again here, it is going to take so much space. We had to type customer beginning, customer end, then orders beginning, orders end, and all of this we had to type. Okay. While in case of this, it's quite simple. It is quite small. Okay. So this is very, very important aspect. Let's have a look at the stocks. So we were talking about this one. Okay. This is how this looks like. Let's take it and try to paste it in the JSON formatter website. There is a JSON formatter. Just search for JSON formatter and you'll get this website. So let's just reformat it to make it look cleaner. Yeah, this looks cleaner too. See that? Alright, it says that it's not a valid structure. You can see that because there is no. Alright, here because of this. Let's just try to make it look as if it's a valid structure and make it an array. Alright, so basically right now our stocks.json is curly bracket started ended, then another new line is a curly bracket. Each one is having some name values. Okay, and here also some name equals to values are there. All right, and you can basically represent everything here using colon, not equals to colon, and so on. Right, so individual line is a valid JSON in this case, but if you see here, either there should be a comma between them, okay, or it should be something like line 1 colon this comma line 2 colon, or it should be like this. Okay, therefore the default format which stock.json is having does not have the valid structure. Okay, but these are good. This kind of format is good because we will be able to use the text file technique. Ishwar is saying, do we need to always make sure that objects are serializable to work on clusters? That's correct. Our object, whatever we are sending, they should be serializable. Okay? Because most of the time, at any point of time, the RDD fails or something happens. Okay, so the persistence, the serialization, the network transfer, everywhere the same logic of converting your object into storable data should be there. Okay, you should have a way to convert your object into storable data, that is serialization. All right, good question. So is the JSON clear now? So Ishwar's question is, so there is a lot of serialization and deserialization. It's a tough one to answer. So there is, yes, to some extent there is a lot of serialization and deserialization, but as compared to other frameworks, the framework Spark has the minimum amount of serialization, deserialization. Why? First, it tries to represent everything in the memory, and most of the time in case the RDD is lost, it computes it from the beginning. Okay, unless you have created a cache explicitly marking that we want to store it as the local object. Okay, only in those cases your data will be serialized. So G10's question is, so we can serialize bitmap etc? Yes, of course. All right, so if you, let's say, whatever we discussed till last time, okay, whatever we discussed till last time, where is that okay, so you could use whole text file or whole object file to load the full directory of JPEGs. Let's say you are trying to process the profile pictures of 10,000 people, and these profile pictures are available in one folder. Either this could be a compressed one or it could be a normal one. So you could say, we will come to all of those details. You could simply say sc.object files and it will load the full folder, thinking that it's a either zipped file or it's a folder. And using map, you could easily process every object and then generate whatever you want in parallel. Okay, so please here let's pay a little more attention to what we are trying to do. Basically we are trying to load a JSON structured file. All right, and how are we doing it? The way we are doing it is first we took an example of this particular file in which each line is a valid JSON, but as a whole file is the whole file is not really a valid JSON. Okay. Now we had a look at the format. Okay. Now let's try to solve it. So we okay. So let's try to run it. Let me this is bin slash PySpark. All right. So this, when we say import JSON here in this case, we are basically importing our JSON package of standard Python. Okay, and here we are defining a function that basically loads our object. So this input file, when we say, so what have we done? Yeah, we have loaded the input file. We can have a look at what is input file by saying first or take one. So yeah, now you can see that it's plain text representing JSON. Okay, now let's try to convert this into an object. Let's say we create a function called, so what exactly is this function doing? Whatever you give this function in terms of x, that will be converted into JSON object, and afterwards you will be able to extract values from this text. Okay, so this text you see with the curly brackets and all is a JSON object till here, and when we loaded it, it got converted properly into JSON object from a string, and afterwards we could access any value we want. Okay, so for that matter, if we try to take this object, like let me just copy paste it. Let me try to copy paste it. So if I say JSON or say f of this, now you can see it has returned me capital A. And what is capital A? Something to do with, do you see ticker somewhere? It must be somewhere here. Or let me have a look. Did you see? All right, all right. So it must be somewhere. Starting from this side. Yeah, here it is. The first line itself. Okay. So these are the various values, and you can see that this is a complex object. ID is a complex object, while ticker is a normal string. Okay, and profit margin is a decimal number, and so on. You can see that. So we were able to successfully load and test whether it's working or not. So it seems to be working. This function seems to be working. The f function is working fine for individual line, and that's what we are going to do next. What we are going to do next is we are going to call this function as map. Now on each line of our input RDD, we have called this function f, and what does this function do? This function is basically picking up the values of a name called ticker. Okay, so let's go ahead and let's try to do data.collect. Okay, Now you can see that it has, out of the full XML, it has only picked up the ticker. All right. So we were successfully able to process our JSON format. Now, what is so special about this? The special about this is this JSON.loads will load the data parallelly on the whole cluster, because we are calling this function inside our map. And if we remember correctly, our map function will be called on each element once. Therefore, JSON.loads will be called separately on each element. That means if there are say 1 million element, this function JSON.loads will be called 1 million times. All right. Okay. So we converted this. So each first question is, how did it find ticker? We basically, whatever file we loaded, let's say input, and let's say take one. So you can see here that it's a big object representing, it's a big string, it's a string basically. Okay, it's a text string, and inside this text string is your ticker. You see that? And if you parse this string and convert it into object, then you can basically do anything you want. Okay. So if I had let's say a line 1 equals to this. Okay, now we have line 1 this, and if I say json dot loads o equals to json dot load line 1. Okay, now this object o, you can go over it. Okay, you can go over it. Things, say for example, you are trying to compute volatility month. Okay, something of this sort. You can see that. Was this correct? And that's how you can basically traverse into this whole JSON. Let's say you are looking for something. Where was that ID? See that? ID contains another object, so we will have to go on to one more level and try to dereference it. See that? All right. You can download the file from this location. Did we skip anything earlier in the previous session? I hope not. Okay, so we were successfully able to load JSON file, and that too parallelly on multiple nodes. So right now I'm running in a standalone mode. That's another story. But same logic would apply to the cases where we are running it parallelly. Okay, should I move ahead? So that means that even if we have a million JSON objects, we will be able to handle them very calmly using Spark. because we are calling loads in map, which means loads is being called on every node the data is contained. Alright, now moving ahead. You can also save the objects into as text file. Okay. Say, let's say, I mean, whatever we have just done, we can save it as JSON object. But for that, you have to first convert an object into a JSON representation, JSON string representation. Okay. And how do we do that? Using another map. In this map, we are again calling JSON library to convert an object into a string. Okay, you can say out JSON dot take 10. You can see it has converted that into string, and now you can say okay things like this. So we are saying save it to text file into ascii and my output directory. All right. So you can say my output directory, and here you can see these parts. So it has converted each element into a separate line. Okay, that is the that is the that is how you convert your JSON object or any object into text file. All right. Now moving ahead. So if you noticed in our previous example, in this example, we are actually not utilizing any special functionality from the Spark side. All we are utilizing is map. Also, we are basically utilizing the way it's loading the text file. All right. So Spark does not provide any parser. It basically provided a way to execute parser on the whole cluster. Okay. In the similar fashion, if we have to load the tab separated file or comma separated file, we will utilize our programming language library, which does the same thing. So if we are able to load CSV file or tab separated file using some code in independently in Python, you can use the same thing inside Spark as well. Okay, so that's a very big advantage of using Spark over any other system, because other systems have to provide their parsers. Here it doesn't need to, because it's a proper programming language which already have JSON parser, CSV parser, and tab separate parser. Okay, so there are many functionalities of the programming language you can utilize. All right. So the next one is reading and writing to CSV or tab separated format. Okay, and what exactly is tab separated or comma separated format? The records are stored one per line. Okay, one record in a line. Just like your Excel sheet, there is one record per line. Second is there is a fixed number of fields in every line. There is not much difference between one. I mean, there would never be a case where in a CSV file, one first row contains different number of columns, second column contains different number of columns, second row contains different number of columns. So there is no such scenario in case of CSV. CSV, tab separated files, all of these formats are something like structured data, because they have number of fields, they have fixed number of fields every row. all right, but they do not know about the data type of each column, and therefore CSV and tab separated values are generally considered semi structured because we don't know the data type of each value. We'll have to parse it to find it out. Okay, all right, and fields are separated by comma or tab. In case of tab separated file, we get we get row number of detect, we get, okay, we while we are trying to parse CSV file, we also get something called row number so that we can detect the headers. Okay, because the first row of CSV or tab separated file contains the name of the column, which you generally want to skip because you don't want to process names data. Okay, so this is how you can load CSV. It's a standard Python kind of way. So you can import CSV, import string IO, and then load the record. So here, first let's have a look at this function called define record, define load record, and we pass the argument. In this function, we are first loading this line in string IO format because that's what this CSV want. Okay. Now once we have prepared our input, the next thing we do is we call CSV dot dictionary reader like this. Okay. Okay. Now whatever fields we want to process here, we can select only those fields, and then we can basically iterate over the records. All right, so we have this less, so we can actually independently test this kind of function without having to deal with the actual data. Okay, so let's say, all right, all right, let's try to see load record. Okay, and under this we could simply say things like a comma b comma c. All right, so it has imposed these columns onto this data. Okay, so it has converted whatever line we gave into CSV with these field names. Okay, these are the field names. So it will give the first column a name like this, and second column a name as favorite animal. So you can see that clearly. So it has converted it into that record. So what we can do is, given a big CSV file, we can simply do the map. Okay. So we'll first read it as normal text file so that every row is an element in this RDT. Okay. As soon as we load it using text file, every element will be every element of RDD will be a valid object. I'm sorry. While we are simply loading text file, every line will be loaded as an element in RDD. And once we have done that, we will call map. And what will map do? Map will call load record against each line in this text input file, which means it will convert every line into an object like this. Okay, and then we can do whatever we want to do. So this way we are successfully able to load data from CSV file. Is everyone with me? It is not good for the situation where records contain new lines. So what happens sometimes, that sometimes in CSV you have these new lines in a record, right? And as we are talking about text file function, this text file function is going to read line by line, and therefore the record will become sort of two records because it has got new line. Meaning, if your record is spread over multiple lines, it's difficult to use text file function because it reads one line at a time and then does the operation on that. It does the operation on that. All right. So Jitendra is saying, can you repeat which part do you want me to repeat, Jitendra? So there's a question from Gaurav. How to debug in Spark? We will cover it soon. All right, we'll cover it later. There's a session called debugging and tuning Spark. All right, good. So Jitendra has also got an answer to his question. All right, good. Say, for example, when I was talking about having new lines in the file, say, for example, you have an Excel file and in some cells you have pressed enter. That means that cell is having multiple lines. If you export it into CSV and then try to load it in this manner, it's going to give an error. Okay, it's going to give huge errors because the record will be broken into two, and it'll be these text file will be as considering it is a line as soon as it encounters slash n. All right. Okay. Now there's another way you can do. Another way you can do is read the full folder you read the full folder such that each file is represented as a single element of an RDD, and then using map we can convert this into we can load all the records on one node from one file, and then push it, pass it through the map function. Okay, so what exactly is going on here again? We can, in case our file contains slash n, right, then we cannot use text file. if our if each of our value, if either of the values in case of a CSV file, if it contains new line, or somebody has pressed enter, so our normal way of saying text file will break that record into two lines, right? To avoid that, you could load the whole folder, and if you remember our discussion on the whole folder basically, whole text file or whole folder converts it into co- loads the whole folder as if each element of the RDD is the full text file. Okay, it's not great if your text file is really big because it will overflow the memory. Okay, and once you have loaded the text files such that of the RDD each element of the RDD is basically the full file. Okay, then you can use the same whatever we used earlier to load the whole file in a single shot. So that is the way you can handle new lines in the file. Good. Okay, now you can write the records using the same Python library called CSV using writer. Okay, using CSV writer and write the records. All right. So you create a dictionary writer the way we created reader, and then you can use writer.write, and that's it. All right. Gaurav is saying that he can't hear me. I hope everybody is able to hear me clearly. Ouch. Looks like there is no network. It is working. All right. All right. So Jitendra can hear. That means everything is okay. Now, what happens sometimes is that instead of CSV, you have something called tab separated file. The whole mechanism will remain exactly the way we did earlier. The only thing it would require extra is a dialect called Excel tab. So if you have saved your file using Excel sheet, exported it using Excel sheet and said it should be tab separated, then you can use dialect equals to dialect equal to Excel tab. All right. So basically these are the library functions provided by Python itself, and therefore it's quite rich and reliable. All right. Now there's something called sequence files in Hadoop. It's a very popular Hadoop format. It's composed of flat files with key value pairs. Okay. And when I say key value pairs and flat file, it doesn't mean plain text. It could be binary. Also, sequence files have sync markers. Okay, they allow to seek to a point and then resynchronize the record boundaries. Okay, basically, whenever we deal with any file in case of Hadoop ecosystem, they have been designed so that multiple nodes can access parts of the file together, because in case of Hadoop the data is stored in data nodes, right, in HDFS. So when we store data in various data nodes, data will be broken into into arbitrary object, right? Because when the data is broken, the data is cut into blocks. It's always with respect to the size of the block, not whether the data is totally on one node or not. Okay, so generally whenever we are loading something from HDFS, you always have this file in HDFS spread across multiple blocks. Okay, and therefore the boundaries need to be found. Okay, because you need to always find a boundary, and in such circumstances these sequence files matter a lot, because sequence files have give the functionality of a functionality of synchronizing to the markers of the record separator. Okay, so whenever you have sequence files, you separate the, okay, all right. So sequence file provide you a way to properly load data, even if this sequence file is of hundred of gigabytes spread across multiple nodes. All right, is the sequence file clear to everyone? No. All right, any questions on sequence file? Okay, so okay, let me again take a step back and try to explain what does it mean by sequence file. So as we all know that HDFS is not great when it comes to small files, right? So what people do in case they have to tackle lot of small files, say for example LinkedIn, they have lot of profile pictures. Each profile picture is small. Each profile picture cannot fit into is not good enough for the good enough for our block size. Therefore there'll be too many blocks and it will hit these so many files will overflow the name node. Therefore what people do is convert they prepare sequence files out of many small files. They combine them together and create a sequence file. And based on this sequence file, you can do all kinds of churning you want. All right. And yeah, so you can simply load a sequence file using sc.sequence file and give the path name and also tell the data type of key and the value in the sequence file. Okay. And once you have done that, now you can once you have loaded the data, you can do all kinds of maps and reduces and whatever we have read on RDD functions. Okay, so a sequence file will be loaded like an RDD, and then you can execute any function on it. Okay, similarly, you can also save an object as sequence file. You can simply say data equals to sc.parallel list and and the objects, and then once you have prepared an RDD, you can save that RDD by using sequence file sequence file format. Okay, so sequence file loading and saving sequence file is clear to everyone. Yeah. So in case of image, with the example we were taking of the profile pictures, if we are creating a sequence file out of so many image, in those cases, your key will be the file name and value will be the content of that particular image. Okay. All right, let's try to see what happens in this case. Okay, we are saying sc dot r, this is our RDD which we have just created, and you can see what is inside it. Okay, so you can see that it is a proper key value kind of RDD. Okay, and yeah, next is that we can say save this RDD into this particular folder. Okay, now let's have a look at it. Did we create this? This is where the data is. You can see. So we can also have a look at. So you can see it's all stored in the binary format in the file system. Okay, you can see it's a binary format. All right. And in case we want to load this data back, whatever we have just saved, we can simply say sc.sequence file, and if we say f.collect, you can see we are able to successfully load exactly the same data what we had written into that file, right? What we created was key 1, key 2, key 3, and we are back to the same value. The only difference is the order has changed. All right. Okay, let me go ahead then. So, lot of times when we have to deal with larger objects, we would like to store our data in the object format itself. Okay, instead of, because not everything is a text file. Therefore, it doesn't make sense to try to store everything into text file. Okay, exactly for those reasons, object files were provided in Spark. These are nothing but a very lightweight wrapper over sequence files, and values are written out using Java serialization. So whatever, so there is something called sequence files, and whenever these sequence files are being persisted into the disk, the serialization will be used as Java serializer. Okay, all right. So these are intended to be used for Spark jobs communicating to other Spark jobs. Okay, these are comparatively far slower than the other formats available. We will talk about something called protocol buffer, in which which is considered very efficient. Okay, but if you think that your object is not going to be serialized, then it serialized too often, then going with object files is okay. Okay, so you can save any RDD as save as object file, and you can load it using object file. Okay, it does not require any work at all mostly. Okay, and in case we are using Python API, we will have to use pickle file or save as pickle file instead of save as object file. Okay, now there is very important aspect which we all forget when we talk about serialization. Okay, I have faced this challenge very often. And the challenge is the upgradation of objects. Okay, the world could have been very easy if we had these most of these serializations work, but most of these serializations do not work in case the object keep on changing. So today, let's say, let me take let me take this object format again. Okay, so let's say you, okay, so month one you launched your product. Okay, you launched your products and saved all the data in object format. Okay, month two, month two, okay, on the first month you launched your product and saved all your data in object format. Now month two you added one more parameters one more parameter to the object. Okay, now as you add one more parameter to the object, okay, what happens is that your object definition is new while your object already stored in the system are older. Now you will not be able to deserialize such object. Okay, because your older objects which are saved in the disk are in older format, and you have added one more parameter. That means the complete format has changed. Now if you try to load the data into this new object from these old object, it will become impossible. Okay, the only way that was left to most of the people was to upgrade these objects and save them again and maintain both the APIs so that you can read from the old file system and have the newer one. And this was a very significantly big challenge. Okay, it was a significantly big challenge because it impacts globally. So whenever you are persisting an object, you have some parameters, and when you are reading the same object you might have different set of parameters because the object has upgraded, we have added more features, and therefore this scheme does not really work in the end user scenario where end user is trying to use the object files. Okay, and that is where the formats like JSON and other formats come into play, and a format called protocol buffer was invented exactly for the same reasons. All right, so if you change the object, old files may not be valid data files, we may not utilize the old files. Okay, Jitendra, Jitendra, I'm coming to the pickle file. So you have any questions related to the sequence file and object files? So a pickle file is Python's way of handling objects. So you can say the way there is serialization in Java, similarly you have pickle files in Python. Okay. So pickle file uses the serialization provided by Python. Okay. And to save a pickle file, to save some data or some object into pickle file, you can simply say save as pickle file. Okay, on RDD. So you can save an RDD using save as pickle file, and also you can load the pickle file by calling spark context.pickle file. Okay, it could be quite slow. Can be quite slow as object. Okay, all right. Okay, so since pickle file internally uses the same object file, so it could be as slow as object files. So Jitan's question is, why do we use pickle file then? Pickle files are used rarely in case of handling the communication between the inside the Spark. Okay. So Spark uses this for only few occasions. So it's a relatively older format as compared to the other formats. All right. Okay. So far we have only discussed how to load the data from file system. Okay. You can also access the data from non-file system data sources such as HBase or MongoDB, or maybe Hadoop or Hadoop file or Hadoop dataset. Okay, so you can basically access all the Hadoop supported storage format. Anything that implements in Hadoop's input formats is accessible from Spark. Okay, so from Spark you can access the data from anywhere, whether it's a file system or another DB. Okay, so the idea is that you basically load the data into RDD or data frame. We'll cover data frames at a later point of time. So RDD is also converted into a data frame. New kind of RDD has come in called data frame to accommodate R and other similar tools. It takes a configuration object on which you set the Hadoop properties, and earlier there were these two APIs for called Hadoop file and save as Hadoop file, and now there are newer ones called new API of Hadoop dataset or save as new API of Hadoop dataset. Okay, so you can basically load key value pair objects from MongoDB, or the row key and the row from HBase as a single element from an RDD. Okay, we'll discuss protocol buffers today itself. Ishwar is requesting for, let's take a break at 8:30. All right, just 5 more minutes. Okay, you could load data from Hadoop using Hadoop file, and you could provide the Hadoop path, the file path, the input format class. I mean, how are we going to read the data from this file? Okay, the key class, the value class. Okay, so since we are storing data in input format, it would have something called key and the value. All right, and therefore we need to provide the data type of key value. Also, we can optionally provide key converter and value converter kind of services. Okay, you can basically read anything from Hadoop into Spark. All right. Now, in the after Hadoop 2.0, this new API does a very far better job than the older API. So I would strongly recommend that you use this particular file, this particular API. Okay, you use new API Hadoop file, and instead of, okay. Now, so you can call this and from Python as well. It's not only the Java case, you can call it as Python. And the configuration you can provide as the Python dictionary, right? All right, there's a question from Jitender. The question is, we did not talk about Avro. So Avro is a format provided by Hadoop. So whenever you are loading the data using old API or new API, you can mention here that we are talking about Avro in the input format class. Okay. This way we'll be able to load the data from Avro as well. Okay. Any questions at this point? So effectively, in Spark, we can load any data we want. All right. Also, please keep in mind that whenever we are saying Hadoop file, it will take care of the data locality. So whenever we are executing the RDD, whenever we are executing functions on top of RDD, okay, whenever we are executing functions on top of RDD, and 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 this data inside RDD is located somewhere really far. So Spark will try to execute your logic, your function, your actions near to the data. Okay? Near to the data. Alright? Any questions at this point? Alright. There is a question from Gaurav. Question is, so we can load data to Hadoop HDFS using Flume or Scoop, and then we can use Hadoop file to load the data into RDD. That is correct. Okay. So not only that, you can load the data into your MongoDB, and then you can use the Hadoop file to load the data from MongoDB. Okay. It is very much possible, because anything under Hadoop, as in anything that implements an input split or input format, is readable from Spark as of today. Okay. So, all right. I will show you sometime. We have something called Mongo Hadoop kind of implementation. You can simply define that as your input format class, and then you will be able to talk to MongoDB from within this API. Okay, all right. We will go into the MongoDB part. Maybe we'll try to prepare an example. Okay, but anything that implements input format, we should be able to talk to that library. Okay, that is the whole idea. All right, let's take a break and then start with the protocol buffers. All right. All right, I'm back. Sorry for being a little late. All right, should we start now? Mehndi, Jiten, Gaurav, Ishwar. All right, there are a few things which we were discussing before taking a break. One was a question from Gaurav. Okay, so Gaurav, I'll just explain to you. Okay, so your question related to how will we read using this API from MongoDB. I think this is best answered here and also has been written in the comments. Okay, so you can see like this. So first, you prepare something called config object, in which you give out the URI information. This is your MongoDB. I mean, you have to mention in the protocol instead of saying HDFS or file, you say MongoDB, and then you provide the host name, and then you provide the namespace and collection, and afterwards you provide the input format class name. This is the class name. Okay, and once you have the key and the value clear, then you can use this Hadoop RDD. Okay, so you can say sc dot new Hadoop RDD, and then you could provide this input format class as I was telling you. Okay, and the key class name and the value class name, and also the config. Okay, and now after this you can basically you will get an RDD representing each collection will be an element in this RDD. Not each collection, each document. Okay, each document will be, make sense to you? So the URL would come from the config, while the input format class will be this one com.mongodb.hadoop.mongo input format, and rest will be same. Okay, so all right. No, the executors or workers, all the workers will read from MongoDB. Okay, all the workers will talk to MongoDB and read from MongoDB. If your MongoDB is protected with login password, you will mention that in the config object itself. Okay, so the overall objective of this Hadoop RDD is one, providing the data locality, as in even when these workers are being executed, whenever we do map reduce, it will do it near the MongoDB server, which is nearer to our host. So data locality is something which has been taken care everywhere. Okay, which has been all of these API, the way they work is, even in the case of Cassandra, Avro, everything in MongoDB, everywhere, the data locality is a very important premise. Data locality is a very important premise. All right, so does it make sense to you now? So here is another big example. You can try to have a look here. Okay. All right. All right. So next question from Gaurav is MongoDB locality is taken care by framework. So the way it happens is when MongoDB has implemented something called Mongo input format, which is an extension of input format provided by Hadoop. So when we access that server at MongoDB, it makes it possible to access the data. Along with that, it will tell us that this data is in this IP address, that data is on that IP address. Okay, so effectively whenever somebody is implementing input format, they also give out the information about the data locality, right? If you remember our input format long back when we discussed, the input format's definition contained the location of the data, the IP address of the data. Now, based on the IP address of the data, the the Spark will take care of the data locality. It will try to execute maps or reduces nearer to the data rather than farther to the data. Okay. Therefore, whether you are accessing Hadoop, Cassandra, or MongoDB from Spark, it will take care of the data locality. And what does it mean by data locality? Data locality means the logic should be executed either on the same node as the data, or very closer to the data, because the network transfer of the data in case of big data is really big time consuming task. All right. Therefore, no. All right. So that is how it is. All right. I hope I was able to explain, Gaurav. Great. So, this Hadoop file and Hadoop new API file, they are exactly same. The difference is, and those somebody asked about Avro, right? So if you are reading an Avro file, here you can give the input format class of Avro. Okay, and that's it. You will be able to read the data from Avro. Okay, so where is that? Yeah, here. So you could actually use this format, input format, like this. Okay, com.databricks.spark.avro. That should be good enough to read the data from the Avro format. All right. Good, great questions. So should we move ahead to protocol buffers? All right. So there are many formats. Let me just list them down for you. We we talked about CSV, or tab separated. Okay. CSV tab separated format are good for tabular structures. Okay. Then we talked about key value kind of formats such as sequence files. Okay. Now sequence file, or say, then these are like small ones. Then the other format, so I think let's not include key value here. So we are talking about generally representing the data. So this cannot represent many structures. Okay, this can only represent a flat structure of tabular. JSON, XML, thrift object, and Avro. They are all, these are the few generic ways to represent the data. Out of these, these are binary formats. Okay, these are plain text format. And then, so lots of people realize that specifically, I mean, people who were using XML, that it is a very overhead. I mean, it's extremely slow. Okay, JSON is fairly smaller, and JSON provides you a good abstraction from the internals of the data. It provides you a good way to access the data by the way of arrays and all of this. While in case of XML, you have to, the traversal is actually very time consuming. Now, the problem with XML or JSON, other than the size, was if you store your data in the older format, okay, and you have to load this data back, there are high chances that you will end up in nowhere. Same is the case with other object format. Even this Java object format, if you even reorder the things, let's say you refactored the day your classes and you reordered some of the objects, now the data which has gone in Java object format is no longer serializable. That's why people do not store data using Java serialization so often. Java serialization people generally use for transferring data in the data center from one location to another. All right. So there are many serializations in place. Everyone had their own issues. The only one that came up with, okay, the only one that came up with the object versioning and the ability to take care of the upgradation, graceful upgradation of object, it was thrift and protocol buffer. Okay. So in case of protocol buffer and thrift, in both the cases, you can mark the new variables as optional. Okay, so that you can load the older data easily. All right, so those were the few examples of the format. But in spite of all of these formats available, because of their own limitations, Google came up with their new format called protocol buffer. We will give you a full-fledged example because I strongly believe that this format is going to be more popular, and is already more popular than most of the other available formats. Okay, and I have used protocol buffer earlier as part of our Google Web Toolkit framework. It was internally using protocol buffers. So protocol buffers was designed by Google for their internal remote process calls. RPC stands for remote process calls. So for their own internal systems, they built something called protocol buffers so that they could call one machine from another internally as well. Okay, and in mostly in these organizations, this specifically service oriented organizations, the way, say for example, Google, Amazon, I have an experience with Amazon, so I'll take that example. I think this will be quite useful to you. So, Team A and Team B, Team B, they don't talk to each other by providing the access to their database. Okay, let's think about a team called Delivery Team. Okay, who will deliver the data, deliver the products to the end user. So you place an order, delivery team will make sure that order gets shipped to you. Okay, now there is another team called website detail based team. Okay, and then there is a third team called Amazon Prime team. Okay, so if detail team, if Amazon Prime team needs to access some data from delivery team, they would not ask for the database access. They will not talk in terms of database tables. They will instead expose their APIs. Okay, so everybody like delivery team, web page detail, website detail team, all of these teams expose their APIs, expose their services so that people in the organization can access these services over the network. And And basically there is no need of human intervention, no need to chase anybody to find out about the services. So say for example, I was in a detail based team. Our detail page actually used to make around 50, more than 50 calls to other teams API. So when you try to render the detail page, when you try to render the detail page of Amazon, it internally makes 50, more than 50 calls to other services. Okay, so basically the main point I'm trying to drive here is, in most of these organizations, the time is gone when the teams used to communicate via the database. Okay, you look at other people's database and you start querying. That time is gone. Okay, now everybody in organizations, they segregate their duties by saying that we will be providing API for this functionality, and then all of these teams talk to each other via those APIs. Now, same when at Google it was the story, and therefore they realized that if they can make this service calls really fast. And when we are making service calls, the data or the objects which we are returning need to be converted into a string, because it has to be transferred, saved, and everything. So the data has to be serialized. Now, serialized, if if they serialized or they give out the data in XML format, it could have been really expensive. Or had it been in terms of the JSON, it could have been still more expensive. And when I say expensive, one, it should not consume, this kind of format generally consume lot of network bandwidth. Second, it takes time to deserialize and serialize such data. It takes time to deserialize and serialize such data. All right. Was this example clear to you? Why did Google need this internal RPC? No? So there is a team A who does something, team B who does something. If they need anything, any data from each other, or whatever, or in other words, whatever team A does, they expose it like an API. Similarly, whatever team B does, it is exposed by team B as API. And everybody in organization can just call their API. Is that clear now, Jitendra? Yeah? Feel free to ask. Mehdi? Alright, very good point. So question is that his point is, then what's the difference between looking into database than looking into API? Okay, so if some team exposes their database tables to you, okay, then you might I mean, it's called segregation of concerns. So let's say I expose the database table to you. You will be starting to query this table without me having any control over what to tell you and what to avoid. Okay, because I'll be keeping lots of internal details in this table. You will get confused, utterly confused, if I just tell you that this is the table. Also, sometimes we do not want to expose the details to each other. Think about user info team. Okay, user info team's responsibility is to maintain the information about the user. Okay, information such as your address, your credit card details, and everything. Now this user info team can never expose this information to even the people in the organization. Okay, therefore giving the table access is very bad practice. Now it makes sense. Yeah. So if you give access to the database, if you start looking at somebody else's data, you're looking at their internals. All right. Now, good point. Good point. His point is that why don't you use table view to show what to not? Okay. There are many reasons actually. So one, these APIs can choose to selectively cache. So they have, when you give a service to somebody, you have far more control over what to show, how to show, and when to show. Okay. For example, you could have even the caching layer in your API so that you don't keep hitting the database. And you can do the caching partially. All right. So you could do a lot of intelligent stuff on top of that database. Okay. So that's the reason. Ishwar's question is, so they will be having multiple return types for each API. Yes. Yes. So when I say third party also means the team inside the company itself. Okay. All right, great. So what Google realized was that when they were making their products public, they realized that almost all of their products are depending on protocol buffer. And unless they make the protocol buffers public, they won't be able to make other products public. Therefore, they decided to open source it. Okay, so protocol buffers are considered as structured data because you have fields and types of fields defined. It is great at encoding or decoding fast. Encoding, decoding, and serialization, deserialization is 20 to 100 times faster than XML. Now, when somebody says 20 to 100 times faster than XML, it is very important aspect. Okay, so let's say some people from Dell were visiting this Friday to discuss their architecture diagram. All right, I'll give you a good example now. Okay, so some people from Dell were visiting this Friday to discuss their architecture diagram. So they had around 445 million events. Okay, and each event, so these kind of events are happening in their organization and are being pushed into a big pipe. Okay, so so many events are there, and each event is around 2 kilobytes of XML. Okay, so 2 kilobytes of XML is what these 45 million events are. Now, so how big it becomes? 45 into 45 into 2, this much gigabyte data, which is 90 GB data. Okay, so this 90 GB data every day has to be transferred. Okay, now think about it. One is that it takes time to deserialize serialize XML. If that is made 10 times faster, okay, along with that, if we decrease this size from 2 kilobyte to how much? Say zero point 0.2 kilobyte. Suddenly, your transfer for the day will become 9 gigabyte per day. Okay, if 2 kilobyte size goes to zero point 0.2 kilobyte, then 9 gigabyte per day, which is far easier to handle as compared to 90 gigabyte every day. Okay, now your most of this problem has been solved just by a single decision of going for different input, different format. Okay, you can see from 90 gigabytes to 9 gigabytes data is something you have done. Okay, sounds good. Because this is, it takes a less amount of space than XML, which is 3 to 10 times. Okay, so all right, now your data in data out can be in protocol buffers, and you could create your own language, or you could use these protocol buffers in any language. It doesn't matter. Okay, also the way protocol buffers work is first you define the data type. Let's say you are trying to store customers. Okay, you will first define a class called customers in protocol buffer format, and then you compile this data, this header information, and then keep it with your data. Okay, so this, unlike JSON or unlike XML, we keep on defining the same variable again and again. Here that's not the case. All right, so you basically define whatever objects you want to serialize, you define them using protocol buffer format, and then compiler generates accessor methods in various languages, variety of languages. It consists of three keywords called optional, required, or repeated. Optional means this particular field is optional. Required is mandatory. If that object, while serializing, deserializing, it will throw an error if the field which you are trying to, which is mandatory or required, is not there in the data. Okay. So whenever you are adding more fields to your object which has been already in the production, so there is you shipped your last version with some definition of a product. Now you realize that you just want to add one more field. Now you must have already created data by serializing this kind of format. So effectively, when you try to deserialize the old formats, it would keep on giving error. Therefore, what do you say? A tag like optional, required, or repeated is very helpful. So if you are adding more fields to a class, just mark that optional, and then you don't need to upgrade anything. All right, let's try to see if it works or not. All right, so if you are trying to you are trying for protocol buffer, download and install the protocol buffer compiler first. You will have to first download and install a protocol buffer compiler, and once you have done that, you can generate the class. You can generate the class, or you can generate the wrapper class over your protocol buffer example, and using that class you can serialize, deserialize your objects. Okay, I will show you. Let's say this is your file. Okay, I have created an example of the same thing here in this one. Okay, how can I send it to you right away? All right. All right. So you can download and install the protocol buffer compiler. I've already done that. Okay. So where is, yeah, I have created the code here. So let's just see. So first we created something called addressbook.proto. What does it do? Is the font big enough? Is this font big enough, or should I increase the font? All right. So look at this tutorial here. So first of all, we have this is protocol buffer kind of a language. It looks like your Java or C++. Okay, a little more cleaner than those. It has a definition at the top called package. Package tells address book that package tells protocol buffer compiler that this is going to be a package in our project. Okay, now inside that there is something called message. A message is basically a big object inside which you can have either the primitive data type like string, integer, and string, or you could have a complex data type like enum. Enum is like a single variable in which only these three values can come. So if you are defining a variable of type phone type, you cannot have anything other than 0, 1, and 2. Okay. So, and then there is a phone number, which is optional, which is uh, basically another object inside person. And this object contains further definitions. And also there is an example here which shows you to define the default value. Okay, so whenever you are upgrading your product and shipping it, other than saying optional, you can also say the default value should be this. Okay, that way you can have the complete backward compatibility in your objects. Okay, for backward compatibility, this kind of strategy is brilliant. Even if you are not using big data or Scala or anything or Python, this tool will be quite useful to you in general. Okay, so once you define your class like this, and here when I say repeated means it's going to be an array of these. When I say repeated, it means an array of phone numbers. Phone is an array of phone numbers. Okay, now like you can see here inside address book there could be a full array of such things as array of persons. All right, now next is let's compile this. And how do you compile? By saying, I'd already done this nicely. So run.sh. So here you can see, so my source folder, let me just define my source folder. And my destination folder is say code. And let me run this command. Now when I run this command, it will automatically create things in destination folder. Okay, now here you can see it has generated these classes, right? It has generated these classes. Okay, these classes are the one which are going to help you to convert any object into a protocol buffer object. All right. So these are the classes which have been automatically generated. Okay. Where is my example of protocol buffer? I think in this project, yeah, it is in the project itself, here itself. So you can see read and write are the two, and there was, okay. So these are the two files which I created, or all right. So read, write, Spark, protocol buffer. Let me try to show you with those. All right, it's not allowing me to do this, so I'll have to copy all of this. All right, so this was, all right, here. Okay, so this was our protocol buffer definition. So we are trying to store persons in the address book. For that, we have created these three objects. These are Python code right now. All right. So it has generated this stuff in Python. Also here, we could, when we are saying Python out, instead of saying Python out, we could have said Java out. Okay, it would generate, the Java objects for our class. Okay, all right. Now here, what's going on? So inside code, you should see Java as well somewhere. It is not there. Yeah, it is there. So inside, it has created the full folder called tutorial, in which it has created Java. So what we have just seen, whatever language we want, we can convert this address book.proto into. All right. That means you should be able to have protocol buffers used in any of your programming languages. All right. Now let's have a look at three things first. First is, let's take a look at normal. What happened to this guy? Yeah, here you can see, basically we have defined a function called list people, which is asking again and again your name, phone number, etc., and then saving it into address book. Then it's saving it into address book. Okay, that's all. Now next one is write.python. It is basically save whatever. I'll show you again. Vim.python. Okay, addressbook.python is something which is generated by protocol buffer compiler. Next is your read.py. Read.py reads a file written using protocol buffers. For example, you take this case. So we are reading whatever file is being passed as argument. We are reading that file. Once we have read that file, we are saying address book, the address book which we have compiled, address book dot parse from string, and this is our data. And address book dot parse from string translates this data into something meaningful, and then you'll be able to present it as an object. Okay. So address book dot parse from string will create an address book containing all the objects, and then listing it, as in printing it onto the screen. Okay. Next is, if you can see right, this is how we created this data. As in, we created first person, we created its name, ID, and email, phone number, and then at the end of, once we have created the particular object, we saved this in the we saved this object. I'll show you how. So here, if you see, we have person we are passing. Okay, we're passing person to something called prompt for address. Okay, and here we are. So here we are saying prompt for address addressbook.person.add. It gives an empty person object which is filled by prompt for address, and once that is done, it serializes the address book and saved it into the disk. Okay. So what we have done just now is we are reading writing without any Spark intervention. So we can read write the whole file using any language using protocol buffers. Okay. Now the next thing which I want to show you is my this one. Okay. So let's have a look at this one, which basically tries to write the data using protocol buffer and read the same data using protocol buffer. Okay. So first of all, we import the address book, which have been automatically generated code. And once that is done, we get an access to the address book object by importing that one. Next, we create this array called persons, and then we start creating person. So every time we create person, we say address book dot add, which creates a new person empty object, and then we append this empty object to our persons list, and we keep on doing that. Okay. And once we have done this, then we basically can save this object, save this object, move this object to RDD. Okay, we can move this object, whatever we just created, into RDD, and then serialize to string. You can convert this object into string very easily like this. Okay, so serialize equals to person RDD dot map, and then serialize, and then we can save it to the text. Okay. Okay, so this serialize will serialize one person at a time. Why? Because our RDD contains is basically, our RDD is an array of persons, because we have given it an array of persons here. Okay, sounds good to you, this example? No, doesn't ring a bell? Gaurav, Jitendra, Ishwar, Mehdi. All right. Yes. So these classes need to be embedded into your existing code. Okay. You'll have to copy. This is automatically generated code. You can just copy it in the same folder and then start using that. All right. Great. Great. Moving ahead. So this is how you could use protocol buffers with Spark. First, we tried to show you how you could use protocol buffers on any object, and then we went ahead with only single object, or with multiple object, but with Spark. Okay, so that's what we did. All right. Now, as I was telling you, that just changing the data format from XML to to protocol buffer might save you, at least it might make your data really small. It converted, in our case, it converted into 9 gigabytes from 90 gigabytes, and the difference is really obvious. Okay, so the impact of minor optimization in case of big data is really more impactful. Similarly, the other way you can minimize the data transfer, or other way you can minimize the storage, the volume and velocity both. If you have to make both faster, you might have to invent something, you might have to use a better compression. Okay, although invention is happening for every 5 years or every 2 years or so on file compressions. Okay, so you just have to use a better compression techniques. Okay, you need to understand why, when to use which compression technique. With almost every Hadoop format, you can specify compression codecs. Okay, so compression codecs is like having, like for the movies, that even though the file format is in JSON, or file format is in Avro or protocol buffers, we can apply a compression on top of it while reading and while writing. This comes in the form of codecs, and every input path like text file, Hadoop file, all of those functions provide a way for you to configure the uh, configure the compression. Okay, so almost every one of those provide you a way to so Ishwar's question is, are you going to discuss thrift object? I'm not going to discuss thrift object, but strategy with thrift object is exactly like protocol buffers. You first write the thrift object definition in thrift language. Thrift provides a language like protocol buffers. You create that, then you compile that using the thrift class, thrift compiler, and the thrift compiler will generate the code, and then you can take that code and start using in your tool for all the CRUD operations, all create, update, delete kind of operations. And yeah, so yeah, Gaurav's question is, RC and ORC file formats are also common in Hadoop. I think we also have input format. Yes. So almost all those formats which you see, you just have to, while defining Hadoop file, you just have to mention the file format, the format type, and that will be good enough. All right. All right. Now, So although compressions have been there for quite some time, not, I mean, since the communication started, the communication engineering, all the there had been the full history of compression algorithms. Okay, the only thing which is new in case of compression algorithm is this splittable kind of compression. The compressions which do not require the whole file for uncompressing it. Instead, it can be compressed in parts. Okay, that is splittable compression format. Okay, so there has been a lot of work on splittable compression formats in recent times, and therefore we have really good robust compression types as of today. Okay, this is a quick note on what is available as of today. All right, there is a question from Gaurav, sorry, Ishwar. What is compression between is what is comparison between protocol buffers and JSON files? Okay, let me just try to do a brief comparison. I don't have exact numbers, but all right, if we compare JSON versus protocol buffers, okay, so protocol buffers are more verbose. Okay, what is the best way to write it? Okay, more verbose, less verbose. Okay, which means protocol buffers will take less space and less bandwidth, slower to serialize and deserialize. Protocol buffers are fast. All right, next is the backward compatibility. Not there. Okay, and in case of protocol buffers it is there. Efficiency wise, protocol buffers are far more faster than the JSON. All right, so on these three parameters I found protocol buffers really good. The only thing which is this is plain text, and so it's very readable, while JSON, the this one is not readable. All right, so Gaurav's question is protocol buffers support versioning. That is why it is no, it is because of these things. Do you see that here? There is a keyword called required, optional, and then there is something called we can define default. Okay, that is why. Okay, all right. So this is a vague comparison of various compression algorithms available. So the compression gzip has been there for quite some time, And if you want to use a ggip compression, you can simply, while saving the data, you could provide an argument saying compression codec equals to this class name, this particular one. Okay. All right. So ggip is very fast. I mean, fast enough, and is quite effective on plain text. Okay, but is not splittable, which means whenever you have to unzip a document provided by Gunzip, when you have to unzip a document which has been compressed with ggip format, okay, you will require the whole file on a node to decompress it. Therefore, ggip is not great for Hadoop kind of infrastructure. All right. Now there is this nice format called LJADO. LJADO is really, really good file format. LJADO is really good compression in the sense that LJADO is splittable. Okay. So most of the data in Hadoop, in my experience, we have generally stored in LJADO format. So that while churning, we don't have to bring all the file together and then unzip. It can work parallelly using splittable format. All right. So LJADO is good. The only downside of LJADO is you need to install LJADO on every worker node. Then there is something called bzip. We call it bzip format, and bzip 2 is something which has been recently revised. Earlier bzip format was non-splittable. The newer one is splittable. Okay, but it's still slower as compared to LJADO. Now there is another compression format called JADlib. JADlib used to come in with Apache web server, and it's a very popular library in case of Unix ecosystem. It's not splittable. Okay, so out of all the formats, LJADO and bzip is splittable, while rest of them are not. So therefore, but bzip is slower than LJADO. Therefore, we are left with one single choice called LJADO in most of the cases. Okay, you can see that because our hard requirement in case of dealing with big data is generally with very big files. And if you require more than a transfer of one block to another, uh, or you gathering of all the blocks of a file and then unzip it, it is going to be inefficient. Therefore, we should avoid using these other kind of compression if we are trying to store data in HDFS. All right, and out of LJADO and bzip, we only have LJADO, which is very fast. This one is slow. Okay, so but I mean the bzip does not need to be installed on every node, while LJADO needs to be installed on every node. Okay, so these are the various compression formats. All right. So far we had been discussing how to load data and save data from various kinds of files. Now let's discuss that how can we load data from other systems. Sorry. So let's try to, sorry, I'm actually, all right, let's try to read data from file systems. Okay, so this is how you generally read data, and you can, if your file is in ggip format, you can simply mention that I'm trying to use this particular codec, and it will it will load this data using that particular compression. Now the problem with this is that this file has to be available on all the nodes in the cluster, okay, at the same location. If this file is not available on all the nodes on the cluster, then it'll give an error saying file not found. All right, makes sense to you? Let's try to read the data from the file systems. And okay, so as you can see that in the text file we are reading a ggib file. We can mention here that we are trying to use this particular compression codec, and then it'll be able to work. All right, so to read the data from local or regular file system, you can simply do this. The only problem with this is that you'll have to copy this file to the whole network. Instead, what you can do is you can just read this file without Spark using your Python code. And once you have created an object representing all the data in this file, you can do sc.parallelize and convert that object into the parallel into the full RDD. Okay. You can also read the data from Amazon S3 file system. Okay. It's a very popular file system, and to read the data from Amazon S3 is great if your workers are running inside EC2, because the communication between workers and the file system, okay, has to be really robust. So if your workers are inside EC2, the Amazon EC2 cloud, then the transfer between workers and the Amazon S3 is really fast. Okay. Also, the data locality can be considered only if your EC2 is in your data is in EC2. Sorry, your workers are on EC2 and your data is in S3. So the data locality and all of that is taken care of well by Amazon. Okay. And the path of S3 looks like S3N colon slash slash name of the bucket. If you register with Amazon, they will give you the name of the bucket along with the key ID and the access key. Okay, secret key as well as access key, login and password meaning. Okay, so you take those information from Amazon, create couple of buckets, put some data in those buckets, and then you start accessing using S3. So the fact is that you don't require any extra methods. Okay, you don't require any extra method. So the protocol is figured out by the by this particular first characters up to colon slash slash. So when you say sc.text file and you provide this as, okay, so let's say how will you be reading this file? You'll be reading this file in the following manner. You'll be reading this file in this manner: text file, and then like this. Okay, and also you can set the environment variables. How do you set environment variables? I think env something, sys.env or something in Python. Okay, so you can read the file either using text file or using Hadoop file. If you are using Hadoop file, you can take care of the other formats as well: sc.new API Hadoop file, and then you can read data from there. Okay. All right, so you can read the data from local file system. and then Amazon S3 file system. Then HDFS is of course there. All you need to do is mention HDFS in the protocol, and it will be able to read the data. So we discussed few things about the data so far. One, which method to use. Okay, which method to use. Okay, whether to use text file, object file, and the next was Hadoop file. Okay, so text file you use when you want to from read text data. Okay, object file you use when you want to read binary data. Hadoop file you use when you want to read read sort of key value data from all the systems that have input split implementation. Okay, now this is the basic way. Now all of these accept something called codecs. You can provide codec for compression. Okay, each of these accept something called protocol. Based on protocol, say in text file, all you need to do is hdfs colon slash slash, and you give the name of the server followed by the path name. So the text file itself will start reading from Hadoop, and then it will read the data into RDD, and then you can do all kinds of operations on HDFS. And still, even though you are using text file, still data locality will be considered. Okay. Protocol could be file S3N, or it could be HDFS, etc. Make sense to you? Also, HDFS and Spark can be co-located on the same machines, and therefore Spark will take care of all the data locality things. The way MapReduce used to send map functions only to the machines which has the actual block of data, similarly Spark will send the worker Spark will send the task to those workers which are nearly or co-located on the same HDFS data nodes. Okay. So it basically takes an advantage of the data locality to avoid the network bottlenecks. All right. In every IO method, whether we are talking about object file, sequence file, or text file, in all of those methods, all you need to mention is the protocol colon slash slash and then IP address and so on to to basically to basically make it possible to read from HDFS. Also, since HDFS or Hadoop, since Hadoop and Spark are very tightly coupled, therefore, while installing Spark, go through go through your Hadoop version and accordingly download your Spark. So before installing Spark, you should know exactly which version of Hadoop are you running. For example, we are running Hadoop 2.4, and so you can check that from here. You can basically say Hadoop version. Okay, so it shows you that we are using 2.4 version, and while downloading Spark, download Spark, we download it for 2.4 version. Okay, so it says choose this one. Before that, direct download here, see that. So we have downloaded for 2.4 or later. So while Before you try to read the data from HDFS, make sure that you are having the same version of Spark or not. All right. Next question from Gaurav is: do Spark and HDFS Hadoop are generally in the same cluster? That is mostly yes. Mostly yes. Because if somebody has already bought the hardware, they would like to make use of that by consuming more CPU and RAM. Okay. Okay. And also, when you're using the same cluster, the whole data locality becomes very easy. The next question from Gaurav is: do we use Spark out? We do. We do. On Amazon, Mesos, and on Amazon, Mesos, and standalone. So, but it's very strongly recommended that if you have very active Hadoop installation, you just install Spark on one of the nodes, maybe driver nodes, and the rest of it will be taken. Will Spark will take care of it. All right. It's strongly recommended that you install both the things together. All right. Makes sense to you? All right. Now you can access the structured data if you. So one was we were trying to access the data in the key value format, like here when we talked about text file, object file, Hadoop file. Sometimes you want to access relational data. Okay, in those cases you use Spark SQL. You use Spark SQL. Okay, for the data that has got schema. Okay, schema means consistent set of fields for all record. Same set of fields for all the records in a data set. Okay, for such kind of data set, Spark SQL does a very good job. Spark SQL runs SQL query on data source and gives back an RDD of row objects, one per record. Okay, so you will run your query on the data lying on HDFS, Hive, HBase, or anywhere. Okay, you will run your query on any of these systems and they will give you the RDD, and this RDD is equivalent of a table, and when some RDD is equivalent of table, every element is considered as a row. Okay, every element of this RDD which is written by Spark SQL is a row, and then you can access the values, the fields of the row, either by saying row dot get name, get address, and get whatever in Java. And in case of Python, it's even simple. You can just put the square and dereference it. You can say row square bracket xxx will give us the value for the field called xxx. Okay. All right. All right. Now using Spark SQL, you can query any of the systems easily and can start working on that. All right. Now you can query your Hive system from within the Spark. I'll show you this part. We'll be able to do it very easily. All you need to do is copy the Hive site from your etc. So basically all I did was copy etc hive conf, and there you will see Hive site. Copy it to your conf folder. Okay, wherever you are, you just copy in the current directory. If you copy that file into conf folder, that is good enough. Okay, if the conf folder does not exist in your current folder, create one. Okay, and then you can start contacting to Hive. Okay, so Hive, again, those who are not aware, Hive provides a way to query the HDFS files. The way we are trying to use Spark SQL, Hive used to do the same thing for Hadoop traditionally. Now Spark has made possible to query Hive. Okay, so all you need to do is okay, so all you need to do is find the configuration and create a Hive context object as an entry point, and then you on the Hive context you can start writing your SQL. All right, so it's a very good plain text format for it's a good format of querying the data. You can do 90% of your work inside Hive itself. All right, so as you can see that Spark has taken an holistic approach to read and write the data from almost every system, every big data system. That means it's actually possible to do all kinds of queries and bring all the platforms to a single one. Okay, and that is the reason they have been able to bring Spark R and the data frames and pandas also into Spark. So every day I see a new platform being merged or being made compatible with Spark. All right. So that's pretty much about it. I would like to show you how to connect with Spark Hive. Maybe we can do it tomorrow. All right. Are you with me? So we will go through this example of Hive tomorrow, and then we will carry on our discussion on the broadcast mechanisms provided by Spark. All right. All right. Thank you very much. Have a great day ahead. Bye bye. All right. Bye Gaurav. Bye Jitendra. Bye Ishwar. Bye Mehndi. Have a great day.